Hello, this is Ben McGahee with McGahee Mathematics, and we have a second video on linear equations. So we just call it Linear Equations 2. And in this video, we're going to learn how to solve linear equations using distributive property, as well as solving linear equations with variables on both sides and looking at an example with some fractions. To end the video. So let's take a look at just the distributive property. We remember going over this. So if you had A times B plus C, and so this equals, so we distribute the A to B, so that's going to be A times B, or AB, plus distribute the A to C, so that's A times C, or AC. So A times B plus C in parentheses is AB plus AC. So we're going to be using this idea to solve a little more complex linear equations. So let's see an example. So if we have 3 times x plus 4 minus 7 equals 11. So the first thing we're going to do is we distribute the 3 x, so that will be 3 times x is 3x, plus we'll distribute the 3 to the 4, so we multiply 3 times 4, that's 12, minus 7 equals 11. Yep. And then the next step is to subtract, right? We have 12 minus 7, that'll give us 5. So we'll have 3x plus 5 equals 11. And to get the 5 to the other side, we have to do the opposite of adding, subtracting 5 to both sides. So that's how we get rid of the 5. So we see the 5's are going to cancel. And then we have 3x equals 11 minus 5 is 6. And then we divide both sides by 3 to get x by itself. So x equals 6 divided by 3, which is 2. X equals 2. And I will let you check on your own to plug in x equals 2 back into the original equation to make sure that the equation is true. And it should be true. So x equals 2. Okay, let's look at an example where we have an equation with variables on both sides. So like for example, if you have negative 4y plus 8 equals 6y, say minus 2. So negative 4y plus 8 equals 6y minus 2. So the goal here is that we have a y here and a y over there. So we need to get the y's on the same side. So since this is positive 6y, we'll just keep the positive term here, and then this negative 4y is smaller. So we'll actually bring the the 4y, or the negative 4y, over to the 6y. And the way we do that is we got to do the opposite of the minus, right? Addition, or subtraction. The opposite of subtraction is addition. So we're going to add 4y to both sides. So those will cancel. And then we're left with, there's 8. And that equals 6y plus 4y is 10y. And then we bring down the minus 2. 10y minus 2. Okay, so now we just have a variable y on one side of the equation, and now we can just proceed as usual. So if this is minus 2, you have to do the opposite and add 2 both sides to get the 10y by itself. So 8 plus 2 is 10, and 10 equals 10y. And then our final step is to divide both sides by 10. And then we have y equals 10 divided by 10 is 1. So y equals 1. So that's the right answer. And then I will give you a chance to plug in y equals 1 here and there in the equation, check to see if that's true, and which it should be true. So notice that the variable is on the right side of the equation, unlike usual it's on the left. So you can say 1 equals y, that's the same thing as y equals 1. So it doesn't matter what side the variable is on, as long as you have the right values. As long as you have the 1 on this side and the y on that side, on opposite sides, and you're okay. So that way is okay. Okay, so what we'll do is we'll start a new screen here to do one more problem. Okay, so for our last problem here, we'll do a different color, blue. This will be with fractions. So this one will be the most complicated or complex linear equation we'll solve in this video. And from time to time you're going to see these kind of equations in your homework or on your quizzes and exams, and you'll have to know how to solve these. So we have 1/5 times the quantity 15z minus 20 plus 9 equals 3/4 times the quantity negative 16z plus 8, and then a minus 6. So looks like a lot, right? Looks like a lot of stuff to deal with, but we'll just take it one step at a time and go from there. So the first thing we need to do is distribute 1/5 to 15z. So we get 1/5 times 15z, and then we'll do minus distribute the 1/5 times 20, and then bring down plus 9, and then this equals, we do exactly the same thing. We distribute the 3/4 to negative 16z. 3/4 times negative 16z. And then plus, we'll have 3/4 times 8 minus 6. Okay. I'm going to use another color here to illustrate how to simplify this. So you notice that the 5 and the 15 you can divide, right, or cancel. So remember, like with fractions, we did that. So 5 goes into 5 once, and 5 goes into 15 3 times. So we notice that 1/5 times 15z, that's going to give us 3z. Right? Because 1 times 3 is 3, and then times z is 3z. And then we do the same thing. We'll do minus, and then 1/5 times 20, cross out the 5, make it a 1, and then 5 goes in 20 4 times. And then so that'll be negative 1 times 4. It's minus 4. So we have 3z minus 4 plus 9 equals, and then we do exactly the same thing over here. We're going to have the 4 goes in negative 16. We cancel out the 4, make it a 1. And then since it's negative, we're going to have 4 into negative 16. It's negative 4 times. And then 3 times negative 4z. 3 times negative 4 is negative 12. And then we just put the z. And then we have plus 3/4 times 8. Cross out 4, make it a 1. 4 goes into 8 2 times. We have 2. And then 3 times 2 is 6. 6 minus 6. Okay. So then we take negative 4 plus 9. Negative 4 plus 9 will give us 5. So we'll have 3z plus 5 equals negative 12z. Now this plus 6 minus 6, these cancel, right? Because that gives us 0. So we can just cross those out. And then we just have, so 6 minus 6 is 0. So all we have left is negative 12z. So we have 3z plus 5 equals negative 12z. And our next step is to get this 3z needs to come over to the negative 12z, right? So how do we do that? How do we get that 3z over to the negative 12z? So we know that the 3z is positive added to 5. So if we were to subtract 3z to both sides, doing the opposite subtraction, then these 3z's cancel, right? So then we just have a 5 here equals negative 12z minus 3z. So if you're adding two negatives together, it's like you're adding, but that value is negative. So negative 12 minus 3 is negative 15, and then we put the z there. And then finally, to finish the problem, we're going to do divide both sides, right, by negative 15. So these negative 15s will cancel. And then we're left with z equals negative 5 over 15. But is this our answer? Is this our final answer? Well, no, because we can reduce, right? Divide each number by 5. So if we do that, we get z equals negative 5 divided by 5 is negative 1 over 15 divided by 5 is 3. So z equals negative 1/3. And that would be our final answer. So that problem was a little bit longer, but just have to be careful, with the steps and distribute first, like we did here. Simplify multiplication with fractions. Combine the like terms on each side and get the variable on the same side of the equation at the end, and then solve for the missing variable. So again, my name is Ben McGahee with McGahee Mathematics on Linear Equations 2, and do look forward to next video. We'll talk about abstract linear equations, where we solve linear equations with no numbers and just strictly variables and just letters.